In this video, we'll give you a defensive checklist, some specific items that you can actually take to your OT environment and work through. These are the controls that would have stopped the attack paths we walked through in the previous video, and they're the starting point for evaluating the security posture of any OT network. Think of this checklist the way you think about a pre-startup safety review. It's not meant to be done once and filed. It's a periodic verification that the fundamental controls are in place and working as intended. Start with the foundation, knowing what you have. Maintain a complete IP address inventory for every OT device. If you don't have one, building it is the first priority. Use the techniques from Module 6. Query ARP tables, check switch MAC address tables, walk the floor if necessary. A passive OT monitoring platform will build this for you continuously once you've deployed it. Any IP address not on the documented list should be investigated and either documented or removed. Verify that OT and IT are logically separated. Check the switch configuration. Confirm VLAN assignments on switch ports. Confirm that the firewall between OT and IT or between OT and the DMZ is in place and enforcing rules. Don't rely on the documentation. Verify the actual switch and firewall configurations. Identify every device with more than one active network interface. Check workstations, servers, especially historian servers, and any device with both wired and wireless connectivity. Document the finding. Assess the bridging risk for each case, and remediate the ones that create unintended paths between zones. Audit your remote access paths, including the ones that predate your involvement with the site. Ask site technicians whether any modems, cell devices, or remote access appliances were installed during commissioning. The ones you don't know about are the ones that matter most. For each OT device, audit what services are running and what ports are open. Use the assessment techniques from Module 6 to build a list of open ports on each device. Cross-reference that list against what's operationally necessary. The question for every enabled service is this required for current operations? If the answer is no or uncertain, that service should be disabled. Replace Telnet with SSH wherever the device supports it. If a device supports both, disable Telnet. Document which devices only support Telnet and can't run SSH. Those devices need additional compensating controls like tight firewall rules, isolated VLANs, and restricted access. And those should be candidates for replacement. Replace FTP with SFTP or FTPS wherever the device supports it. If FTP is required for legacy equipment, isolate those FTP sessions to a dedicated, tightly controlled path. Upgrade SNMP to version 3 wherever possible. Change all SNMP community strings from the defaults public and private. They should never appear in your OT environment's SNMP configuration. Disable SNMP on devices that don't need it. Change all default credentials. This includes local accounts on PLCs, RTUs, HMIs, and network equipment, vendor backdoor accounts, and SNMP community strings. Default credentials are the first thing any scanner or attacker tries. Confirm default deny is in place on every OT firewall. Look at the last rule in each rule set. If it's not an explicit deny all, then the firewall is running default allow. Add the deny all rule and work through the rules above it to verify that all legitimate traffic is explicitly permitted. Review every firewall rule and document the business reason for each one. If you can't explain why a rule exists, investigate before removing it. But a rule you can't explain is a candidate for removal after verification. Remove any allow any rules. Remove rules for devices that no longer exist. Enable outbound filtering from OT. OT devices shouldn't be initiating connections to arbitrary internal or external destinations. Write specific permit rules for the outbound paths that are operationally required and deny everything else outbound. Eliminate always-on vendor connections. This is the fix for attack path 4 from the last video. For every vendor with an always-on VPN or persistent remote access today, replace it with session-based access, a defined process for requesting and approving a maintenance window. Access enabled only for that window, terminated at the end, logged throughout. Require MFA on all remote access accounts, no exceptions. If the vendor's remote access systems don't support MFA, that's a vendor conversation to have. MFA is an industry standard requirement. Enable logging on all your firewall rules, both permit rules and deny rules. Ship logs to a central system that isn't on the OT network itself, so that logs survive even if the OT network is impacted. Establish a log review process. Someone needs to be reviewing OT firewall logs regularly and investigating anomalies. Automated alerting for specific patterns like high deny volumes and unusual outbound connections from OT devices reduce the manual review burden. Build a network traffic baseline. Document what normal OT communication looks like, which devices communicate with which other devices, and on what protocols, and at what times. This baseline is the reference against which anomalies are measured. A passive OT monitoring platform automates this and provides continuous alerting when the baseline changes. After you've worked through these items, the next level is incident response planning. Having a documented plan for what you do when something does go wrong. What's the notification process? Who has the authority to isolate a zone? What are the manual operation procedures if SCADA becomes unavailable? Incident response planning is beyond the scope of this course, but it's the natural next step after the controls on this checklist are in place. In the final video, we'll cover the standards and frameworks that formalize these practices and the immediate actions to take this week after completing this course.